residue classes or congruence classes. Okay, let's understand what these are. First, let's figure out some values. 1 mod 3 is equal to 1. 2 mod 3 is equal to 2. 3 mod 3 is equal to 0. 4 mod 3 is equal to 1. 5 mod 3 is equal to 2. 6 mod 3 is equal to 0. 7 mod 3 is equal to 1. 8 mod 3 is equal to 2. 9 mod 3 is equal to 0. And 10 mod 3 is equal to 1. So these are basically the remainders when we divide these numbers by 3. Okay. So if we look at this, or if we could write it as, for example, this one we can write it as 3 divides 6 minus 0. Or we can also write it as 6 is congruent to 0 mod 3. You can write this as 3 divides 7 minus 1 implies 7 is congruent to 1 mod 3. And similarly, 3 divides 8 minus 2 implies 8 is congruent to 2 mod 3. So, so these are basically the remainders. So remainders are nothing but residues. Okay. And if you notice that these residues or remainders repeat themselves, right? So what we can do is we can say or convert them into class. Residue class mod 3. So here if you notice 1 mod 3, 4 mod 3, 7 mod 3, 10 mod 3. In each of these cases, residue is equal to 1. Similarly, 2, 5 mod 3, 8 mod 3, 11 mod 3, the residue would be 2. And 3, 6, 9, 12, and so on would be 0. Okay. So what we can do is we can write it in a slightly different way. We can say class 1, we can also write it as I1, is nothing but a set of those numbers whose mod 3 is 1, 4, 7, 10 is a set of numbers whose mod 3 is 1. Similarly, we can write 2, I2 is equal to 2, 5, 8, 11. And similarly 0. So residue would be 0 when it is a proper multiple of 3. So 3, 6, 9, and so on. Okay. Now residues of mod 3 would always be one set of 1, 2, and 0. Right? That means the set of all residue classes of integer modulo m represented by im or I by m, and this would always be as 1, 2, actually I should start with 0, 0, 1, 2, and so on up to m minus 1. Now, if A belongs to I, then residue class A belongs to IM and is given by A. Class A is equal to X, where X belongs to I and X is congruent to A mod M. If A belongs to IM and B, class B, belongs to IM, then it is understood that A is equal to B. That means both A and B represent the same class, or intersection of A and B is equal to 5. That means if a number is there here, it will not be there in any of the other classes. So if you intersect I1 and I2, you will get an empty set. Similarly, I2 intersection I3, you will get an empty set. Okay. Now let's look at some of the properties of residue classes. If A and B are elements of the same class, let's say S, then A is going to be congruent to B mod MK. So let's see here in this example itself. Let's take two elements 1 and 4 from the same class, residue class. We can say 1 is congruent to 4 mod 3, or 3 divides 1 minus 4, which implies 3 divides minus 3, which is true. And we can reverse the whole thing. We can say 4 is congruent to 1 mod 3, which implies 3 divides 4 minus 1, which implies 3 divides 3, which is true. Okay, like that you can take any two elements from any one set or one class, and you will find that they are congruent to each. Okay. Second property, if S and T are two distinct residue classes with A belonging to the residue class S and B belonging to residue class T, then A is not congruent to B mod M. Again, we can use the same example, and this time let's pick up 10 and 6, right? So 10 and 6, and see what happens. 10 is congruent to 6 mod M. That means M divides 10 minus 6, or in our case, M is going to be 3. So 3 divides 10 minus 6, 4, which is false. Now let's look at a theorem. The set IM of all residue classes of integer modulo M contains exactly M distinct elements, which is what I mentioned it here. So here somewhere I mentioned 0, 1, 2 up to M minus 1. So that means there are M number of elements. Okay, so let's prove this. So let us say IM is equal to 0, class 1, class of 2, and so on up to class of M minus 1. Now let's pick up one I, which is between 0 and M, where 0 is included. And similarly, let's take J, which is again between 0 and M. And let's say J is greater than I. Okay. Now what this means, M does not divide J minus I, or J minus I is not divisible by M. Okay, here we have seen, here doesn't divide. Okay, so now let us start with by saying I, class of I is equal to class of J, which means what? An element of this class is going to be congruent to an element of this class mod M, which implies I minus J is equal to a multiple of m, which implies m divides I minus j, or we can say m divides minus of I minus j. So if 3 divides 6, 3 also divides minus 6. It's as simple as that. So which means m divides j minus I. And here if you notice, we have a contradiction. Here it says m doesn't divide j minus I. Here we have m divides j minus I. Contradiction between our assumption and our result, which implies that I is not equal to j. Therefore, we can say Im is equal to 0, 1, 2, and so on up to m minus 1. Okay. Proceeding further, by division algorithm, we have A is equal to Km plus remainder, which implies A minus R is equal to Km, which implies A minus R is divisible by M, which implies that A is congruent to R mod M, which implies class of A is equal to class of R. Since R is going to be between 0 and M less than or equal to M minus 1, therefore residue classes A is equal to R is one of the residue classes, which we have already seen. This is going to be 0 or 1 or 2 and so on up to M minus 1. So what this means is that whether you call it A or R, it will belong to any one of these classes in the set. Okay. So that is residue class or congruence class. Usually you don't have just one class, you have multiple classes, or rather m number of classes. That's it for now.